All right, so we're going to take our chapter 3 Kahoot quiz now. Sorry, hopefully you can see it on your screen. Can you see it on your screen? All right, I got a variety of answers. So let's take a look at the problem. So I know it's kind of small up here, so if you can see it on your screen, what's the first thing we do? 8 divided by 9, good. And 8 and 9 are both integers. So 8 divided by 9 is what? It's 0, right? Because they're both integers. So even though it normally gives you a decimal number, because they're both integers, you get an integer. So you just get 0. It just chops it. It doesn't round it. It just chops it. So remember when you're doing division, if both the numbers are integers, which are whole numbers, they don't have a decimal in there, then you get the whole number version and it's just chopped. It's not rounded. And if one of the numbers or both of the numbers has a decimal point, then you'll get the decimal answer. So you get 0 for this. And then if you take 1 plus 0, you get 1. And then if you take 1 plus 1, you get 2, right? So it should be 2. Does that make sense, everybody? Okay. I know that's a tricky one. Okay. Good job. So if you remember, this is a shortcut. So if A is 3 and you do A plus equals 9, what you're doing is you're saying, I want to take whatever A was before and I want to add 9 to it and replace it. So if you take 9 plus 3, you should get 12. So remember, A plus equals 9 means to take A and add whatever that second number or variable is and then replace it. That makes sense, everybody? It's kind of like saying A equals A plus 9. Okay. Any questions? All good. Okay, we got a variety of answers to this one. So the set precision actually gives you 6 numbers. And then the show point means that even if there's no decimal, it actually adds a 0 to make it those 6 numbers. So it gives you 4 zeros at the end, plus the 2 numbers you have here. If you put fixed in there, which there's not fixed in there, then it focuses on the decimal number. But if you just put set precision, then it includes the whole numbers as well when it's doing the how many numbers it has. And then the show point, again, will add zeros to make it actually have that number. So it should be this one. Sometimes just playing around with these different options that you have is good just for practice. So if you want to try that in the online GDB, try different numbers and try like fixed and show point and try like right and left justified and see what it looks like if you try and set up different numbers. We'll practice that a little bit today though. Okay. So what do we do first? Yes, good. So parentheses always get done first. And if you have more than one set of parentheses, you do the inner parentheses first. And then if you have two sets of parentheses, you start at the parentheses on the left-hand side and you work your way to the right. So remember, if things are on equal level, you start at left and go left to right, just like how you read, just think you start on the left-hand side and you read to the right-hand side. So it's the same thing with your equations. You always start at the equals. And if things are at the same level, you start at the equals and you work your way across left to right. So because parentheses are higher than everything else, we do that first. Now, we do have a decimal number when we have 1.0. So 1.0 divided by 4 gives you what? Anybody know? 0.25, perfect. What would, if it was two whole numbers, what would it be if it was just 1 divided by 4? 0, good. So it's a big difference. You have to decide when you're doing your equations if you want that 0.25 or you want the 0. So it gives you 0.25. Now, we don't want to add yet because that's not in the order of things. We have to do multiplication, division, and modulus first. So starting at the left-hand side, right after the equals, we do any multiplication, division, or modulus that we hit from left to right. So the first thing that we hit there is the modulus, right? So 9 modulus 3 gives us, if we were to take 9 and say, how many times does 3 go into 9? It should go in 3 times, but it divides evenly, right? So there's no remainder left over. So 9 modulus 3 actually gives us 0, right? Does that make sense to everybody? So 9 modulus 3 is 0 because it divides evenly. And that's a great question. When we get to a little bit further, we'll have programs that make decisions. And you can test if something is divisible by another number, because you can use modulus. And if it divides evenly and there's no remainder, then you know that it's divisible by it. And so we'll be using that in the future. So this actually gives you 0, and this gives you 0.25. And when you add the 0 and the 0.25, you get 0.25. Does that make sense, everybody? Do you have any questions about that? And that's what the review questions are all about in this chapter, just to make sure that you can do these equations. Make sure you know the order of operations, make sure you understand integer division so that you can come up with the right answers. So that's what this week is focused on. Okay, let's take a look. We're gonna write answers. So if you want some more practice with this, I can give you some more problems just to make sure that you're understanding the order of operations. So what do we do first? The division, good, because addition is later in the list. So when you're looking at it, you kind of want to keep note of this. If you want to make a note to yourself, we do parentheses first, then we do multiplication, division, and modulus. Okay, now these are at the same level, these three. So you go from left to right, whatever you hit from left to right. Okay, and then you do addition and subtraction. Okay, so because there's no parentheses here, then we're going to do the multiplication, division, and modulus next. So I'm going to skip this addition. And so then I do 21 divided by 2. So because they're both integers, I'm going to get an integer. So it's a real simple division because I don't even have to worry about the decimal in there. So when I take 21 divided by 2, I get just a whole number version. 10, good. Yeah, 10. I don't care about the decimal because they're both whole numbers. So 10. So I replace these two numbers with 10. So it ends up being 3 plus 10 times 2. So it ends up looking like this. A equals 3 plus 10, just so we can see. That's what I like to tell students to do is do 2 numbers at a time, write down the result from those 2, and then solve the next 2 numbers and the next 2 until you get the actual answer to put into the variable. So the next thing we do, we don't want to do this because that's not the right order of operations. So we're going to do 10 times 2. So we should get 20, right? And so then A equals 3 plus 20. right? And then we can add because that's the last thing left, right? So 23. And then the last thing that you do once you actually come up with an answer on the right-hand side of the equals, this is called the assignment operator. So what it does is it actually takes this value and it puts it into A. Okay. And so then when I do C out A, this 23 would print out because that's the value that's stored in A. Now that value can be replaced. You can always say A equals something else later and put a different equation or put a different number in there. But as of right now, A is 23. So every time I print out A, it'll just tell me 23 because that's what's stored in there. So it always takes what's on the right-hand side of the equals, solves it, assigns it to the left-hand side, assigns it to the variable, and every time you print or use A, until you change it, it will be that number, it will be that value. So it's storing this value here. That makes sense to everybody, how that's working? Think of variables as a storage place, okay, for storing values. And those values can be changed because it's just a storage place. So you can always replace it with something else. And if you put another value in there, like if I were to say A equals something else later, it doesn't keep the old value, it just erases it. And so it replaces it. So it's like, okay, erase that and put something else in it. So it's storing this instead. So just keep that in mind. It's not storing multiple numbers. It's not keeping the old numbers, it's keeping all track of. And so let's see how we did. All right, good job, guys. All right, so again, if you want some more practice with doing the equations, let me know. You do have to do the review questions, which give you practice with doing those, but you will get a grade for those. So I just want to make sure that you know how to do those before you do that, before you take your quiz. So if you are still confused as to how to do those equations that I put up there, even after we went over the order of operations, please let me know so we can practice that some more. Because it is kind of tricky and it may have been a while since you've had to do anything like that. So I try to keep the numbers fairly simple. I'm not trying to trick you. I'm putting 5,352 divided by, I'm not trying to put really large numbers to make it so that I'm confusing you as far as the math goes, but I do want you to understand how to build the equations. Okay, so I just have a basic, layout here. This is Hello World, so this isn't really what I want. But I wanted to just go in here for a second, and you can do this with me or you can just watch. I'm just going to use this to build a program. I want to change this. I don't want this to say Hello World. I want this to ask for the diameter of a circle. So enter the diameter of a circle. And you can do this or you can just watch. It's up to you. Now, we talked about C in the last class. And so instead of just creating a variable, so before what I would do is something like this. I would say float diameter. Now this is just a variable name, so it could be just D if you wanted. It doesn't have to be diameter written out. C++ doesn't know, it doesn't matter what the variable name is. It could be X, but that's not meaningful because it doesn't actually tell you that it's connected to diameter. So make it something that's connected with diameters. When you're naming your variables, make sure that if you're talking about diameter, you make it D or diameter or abbreviate it somehow that makes sense with that. So before we would have done something like this. This is what you did in your last assignment. But that's not really what we want to do because we're trying to get to a point where the user can enter information and we can take in that information and we can actually work with that and we can display something and they don't have to actually get into our code to change values. So I don't want them to have to get into my code to change this, to be able to see the program have different results. And so I'm just going to declare that I'm going to have a variable named diameter, but I didn't give it a value. I didn't initialize it yet. If you want to initialize it with 0 or something to start, you can. But just in a second, I'm going to do a cin that's going to initialize it with a value. So some people like to put a value in there to start off. You can if you want to. But I'm going to ask the user right here, and I'm going to ask them for the diameter. And so that's going to initialize it with, this is going to initialize it with 0. And then this is going to change it to whatever they say they want the value to be. So replace that 0. So however you want to set this up is fine. So when you're doing C out, the arrows go this way, C in, the arrows go this way. When you run it and you look at it, you may decide you want it differently. If you do it like this and you don't put an end line, then the actual cursor will be blinking on the same line. So if you just put a semicolon and you don't put end line, it'll be on the same line, and that's fine. So now if I wanted to put in whatever number I wanted, if I wanted 6, I would just type that number in, and I have to enter for the program to stop running because it's waiting for me to enter that data. So I'd have to enter a value and hit enter for it to stop. And then that value that I entered, that 6, would go into this variable that I have declared up here. And I do not have to put the equal 0 up here. I can just put that just so I have it initialized. That's really up to you. But I have it in there. I could have made this a double. That's fine. Float saves some space. I don't really need that much precision. So really it's up to you if you want to use float or double. I won't take off for either of those. But again, it just looks a little different just so that everybody's aware, because I want everyone to really understand what we're doing so far. It's just on the next line when you do that. So if I wanted to enter a number, it puts the number on the next line. So it's up to you whether you like it. I kind of like it on the same line. I'm going to take that off of there. I don't necessarily need this. I could put that STD on every line, but I don't like to do that. So I put that up there all the time because I like to not have to do that on my statements. And then you have to put this in order to be able to use the C out and C in. So hopefully this is all becoming familiar to everyone. Is it making sense to everybody? Not too bad. Okay, so far pretty good. Everybody understands this is a variable. That's just a storage place. This is telling C++ that your variable data type is float. That tells C++ that you're going to have a decimal number. It's going to have 6 digits of precision, and right now I just set it at 0. Okay, but then later you put this value in it, whatever they type in there. Okay, so then what I can do is I can actually set up an equation. So I need to figure out the circumference. So I need to set up a variable for circumference, right? So I can just make a float circumference variable. Now I could have just called it C. That would have worked too. And then what I'm going to do is I'm going to take the diameter that I have times 3.14. 3.14 represents pi. I could take it out more places, but I think that's good enough. That's close enough. So we could write this however we want, but make sure that it's connected and it makes sense with the circumference. So you can call it C or CIR, or you can write out the whole word. A lot of people don't like to write out the whole word because it's more typing. So some people will call it C, and that's fine. Okay, and then the diameter is going to come from whatever you enter up here as your input, and then it's going to multiply it times 3.14. This multiplication. This is completely up to you. It doesn't matter to me. Some people like to put spaces in here. That actually doesn't matter in C++. If you put spaces before and after the equals, or you put spaces after the operators and before your numbers and your variables, that's completely up to you. That's just a preference thing. I just kind of jam it together, but if you want to put spaces, you can. Okay, and then what we want to do is we want to find out what the circumference is. Okay, so we're going to do a C out. Instead of just printing the circumference, oops, it helps if I spell it right. We can just copy it because that saves some time. Okay, I don't like it to just display the answer. So let's say I enter a value. Okay, here it gives me the answer, but I don't like how it's just giving me the answer, but it's not telling me that's the circumference. So I always like to put a label with my answer, okay, and instead of just printing answers, because then people get confused. What is that number? Okay, so I don't want anyone to be confused about that number. So we're going to write the circumference is, and then I put a little space there. The reason why I put a space there is so that I actually get a space between the S and the actual number. Do you have to write it as a sentence form? No, you don't have to. You can do whatever works for you. You can just write it something like this. This is just how your output looks. Some people like to do this and like to put a little space there. And then as long as you have a label with your number, I'm happy. Okay. Everybody good? Does that make sense? Okay. So what we have here is fine. You could have actually just taken this and put this right down here. You can actually put an equation right down here if you wanted to, instead of creating that variable. I wanted you to learn how to put equation, how to put the result into a variable so that you know how to declare your variables and everything. But it is fine actually to put, if you're only going to use it one time, it is fine to put the result from the equation right into your output. So you could do that, and that works the same. So it's up to you. Then you don't have to create that extra variable. So some people like to do that to save space. So really, you'll see people's programs start changing quite a bit from here on out, because the more that we get deeper into this, the more options you have to go different ways. And not everybody thinks the same way. And so, some people will have that extra variable, some people won't, and that's fine, unless I specifically say create a variable, because sometimes I want to know that you know how to do it. And if you skip some steps, then I'm not sure if you know how to create that variable. So if I specifically say that, but if I don't tell you how to do it and I just say output the circumference, then you get to choose how you do it. So what I want to do is talk about, is everybody okay with this? Does this make sense? I want to talk about how to format the output, because we talked about that a little bit last week. I want to make sure everybody was with me. So if you're going to do the output, you're going to add another include up here, and the include is going to be the IO man-up. Okay. And then all you have to do is, before you do your cout for your number formatting that you want, you're going to do a cout and see, okay, I would like to have the set precision be however many you want. Let's say we want it to be 2, and then I want to have fixed. So I want to have 2 decimals basically. Okay. And you might not even have 2 decimals sometimes, because it depends on what numbers you pick for the diameter, right? But if I pick 6, then I'll just get the 2 decimals with that. Okay, that makes sense. So watch this. So I want to show you something. What if I take off this fixed and I just say set precision 2, and I do the same number 6? Do you see what happened? Do you see how it just has 2 digits, but those have to be the actual whole number version instead of so the fixed is working with the decimal. To set precision 2 fixed means that you want 2 decimal places. Set precision, when you don't put fixed, means you want that many numbers all together, including the decimals. So if you say 2, you only get 2, right? So if you see this here with the fixed, again, I'll put 6 again just so you can see how it's 18.84. So when I take off that fixed, it actually rounds up to 19. So you see the difference between set precision with the show point or the fixed, as opposed to not having that on there. And the show point ensures that if you don't have numbers there, it'll actually put the zeros there. Okay. So did everybody see that when I take this off here, what happens? So normally I do like to have fixed, because I do like to pick how many decimals I would like to have, but see the difference? It just rounds up to the whole number. So I really like it like this, but I wanted to show you the difference between that. Okay, that's starting to make sense. Everybody okay with that? Okay, so this is pretty easy, and you can do multiple questions with multiple CNs if you want to. You can even do a question that asks for multiple pieces of data, and you can do a CN and keep putting the arrows and take in multiple variables at the same time. You just have to make sure that when you're asking the user to enter like length and width, that they enter length first, then width second. If you're taking them in as length and width, that they don't get reversed. Although if you're just multiplying them, I guess it doesn't matter. But sometimes when you do your equations and you're taking in data, you have to make sure that you specify what order they're supposed to put them in. And so that's why a lot of times do separate questions for what I'm asking, to make sure that if somebody were entering it, they don't enter it in the wrong order, because that's one problem with asking for multiple pieces of information. Then you take it in whatever order you put them in when you're doing the CNs is the order they have to put it in, and that might not always happen, right? So that's just another possible spot for error, I guess you would say. So I like to do separate questions. If you wanted separate questions, if you did need multiple pieces of data, you make sure you do a cout before you do your CN, so they know exactly what they're supposed to be typing in, and you declare your variables ahead of time. And pretty easy, I guess, right? And then you have those values you can put in your equations and work with. Okay, so if I wanted to do like a random number, I wanted to talk to you about this, because this is another thing that was in the chapter. I wanted to make sure everybody understood. So instead of doing a CN for that diameter, I'm going to stick with the same program. I'm going to add another 2 includes at the top for doing a random number. Okay, so I'm going to do an include for the COSC1436, and then another include. And again, you can do this or you can just watch with the C time. Okay, So I talked about this briefly. I just wanted to show you another program with it. So if you wanted to just, instead of having the user enter the diameter of a circle, let's say we wanted to just randomly generate a diameter for a circle. Well, one cool thing you can do is you can use a random number generator, and you can pick the minimum number you want for your range and the maximum number you want for your range, okay? So what you want to do is up here, you want to do an unsigned. Unsigned means that you won't get the negative version of it. An unsigned seed variable, and I'm going to put time equals 0. Now, if you remember from the last class, it does from like January 1st of 1970, right? And it gives you the number of seconds from that. And then you create an equation based on that. So that's what the time 0 does, is it starts back from 1970 and it gives you the seconds from there. And so the problem with just using that rands we saw last week is that it does give you a random number, but it gives you the same pattern all the time. So if you were to do 3 random numbers and then you were to run it again, you get the same 3 random numbers. So it's not really random because it's always seeding with the same number. So it always ends with the same. The second number you generate is different from the first, but the first is always the same and the second is always the same as the last time you did it. So this makes it so that that won't happen. So when you do this srand and you do it with a seed, then it actually will cause it to use that time, the number of seconds, to give you a truly random number. Okay, so then what I want to do here, I don't want to ask them for diameter anymore because I'm not doing that. I'm not taking in the diameter. So what I want to do actually is when I say, instead of saying 0 here, I'm going to see float diameter. I know I put this rand, parentheses, parentheses. So this is actually calling a function called random. And what that is going to generate a random number for you. Again, you can use that rand like that, but you won't get a truly random number unless you seed it first, like we did above. And you're going to see modulus. And then what you do here inside parentheses is you take the maximum number minus the minimum number. So like if you wanted to range from 1 to 10, right? Then you would actually take 10 minus 1. Okay. So if you want to range from 1 to 100, then you would do 100 minus 1. It doesn't have to start at 1. That second number could be whatever number you want. So you can get whatever range you want by putting maximum minus minimum number that you want. Okay. Then you want to do +1. I know that seems strange. And then on the other side here, you want to do plus the minimum number, which in our case is 1. Okay. Now, if this is tricky, what some people like to do is they like to create variables to hold these numbers. And so you could create a variable for this. So I could say like int max equals 10 and int min equals 1, right? And then I could say that this is max and this is min. So you can kind of keep an equation and this is min, okay? And then this is always going to be +1, okay? So these are numbers that are changing based on your max and your min of what you want your range to be. And so you didn't have to do that. You could just fill in the numbers. But if you put the variables up here, then you'll remember hopefully the equation of how to do that. And these aren't going to change. So you can put that they're constant. They're not going to change throughout the program. Basically, once you declare them up here and you give them a value, these variables don't change. That's why I capitalize them. So constants get capitalized so that people know they're constants, they don't change. So whenever you set your max and your min, that stays your max and your min for the whole program. Do I have to do that? No, it'll still work if you don't do that, but that means you can change them later if you want to. Okay, so this should generate a random number and put it in diameter. Now, this is going to print the circumference that I have, but it's not going to tell me what the random number is. So I can keep running it. And it's going to tell me, well, it should tell me different circumferences. I shouldn't keep getting the same one. So that's not good, right? So I have to figure out what's wrong with this. So good troubleshooting. If I'm only printing the circumference, I don't know what the diameter is, right? So I should print out the diameter as well, right? I didn't really need to print it before because it was written right up above because they entered it. It said enter the diameter and they entered it. So it was sitting right there on the screen. But now I kind of need to print it off. Now, so diameter, okay. So let's see what it is. Oh, it would be nice if I put like maybe an end line in here. So it does look like it's getting 10 here. I did get a different number. So maybe I just happened to get the same number twice. That does happen. If I'm getting a number from 1 to 10, you could generate the same number twice. Possible, right? It's going to generate an integer number from 1 to 10. So any number from 1 to 10, it could generate the same number twice. So it could generate 10 again, but it didn't that time. It did 9. But it's good. I believe it's good to do this line as well. I don't like to just do this because I like to see what the diameter as well. I like to print all my information unless the information that I'm printing is data that I already asked them for up above and it's right there and they can see it. I do like to print the labels and have all the data down here. But do you see it should be giving me a number diameter of 1 through 10, right? And I like having the variables here because that gives me an easy way to change these. Like if I did decide I wanted a larger number, like I wanted 15, I can easily just change this max here. And it can change. Now, it happened to be 12 this time. Everybody with me? Okay. You could even set it up. Oh, you're all super excited, right? You could even set it up so that they do the max and the min, right? A user does the max and a min. So we could actually do like what would you like the range of the minimum for the range of numbers and what would you like for the maximum range? And then you can save those as instead of 15 and 1, whatever they say they want it to be, you can save those in there. That makes sense, everybody? Okay. So do we have any questions about this? Is it working for you? Yeah, okay. Is it pretty easy? I'm trying to go slow this time. I went a little faster last semester and I lost some people. So I'm trying to go really slow because this is the foundation for everything we're going to do in here. And if you get lost at this point, if you don't understand variables, then nothing else is going to make sense in the class. So there's no point in trying to explain conditionals or loops or arrays because none of that's going to make sense if we don't. So I'm trying to go slow, make sure everybody understands that your variables need a data type. They do need a name, how to build equations, what's the order of operations, how do we output things, how do we format the output. And so everybody understands that so that when we go to the next step, which is conditionals, and we start talking about decisions that we make that's based on variables, everybody understands how those variables are stored and how it's working. And if you ever get a problem, like sometimes what students will do is they'll try and do something like this because they're just like copying and pasting, and then you have a problem. And so I want you to understand what's going on here. You don't want to have this variable declared twice. Okay, you want to make sure that if you're declaring it here, that the second time you just take off that declaration of it. So when you have your variables, you should always just say the data type one time, not say it like when you're copying and pasting, not say the data type more than one time. You can reuse the variable, like I can use and say diameter equals as many times as I want throughout my program, but it can't keep saying float diameter, float diameter, float diameter, because C++ is like, you told me it was a float, don't keep telling me that. Like you told me one time, that's good. Like tell it before you, and you have to tell it before you use it. Like I can't move this line down, if this makes sense. It's gonna have a problem with this, right? I can't say use diameter. Oh, wait. Okay, yeah, it is a float. Like after I try to use it, because it's gonna complain. It's gonna say, I don't know what this is. This wasn't declared. Yeah, because it was declared the line after. So you have to, sometimes the order doesn't matter. Like it doesn't really matter if I put this variable right before I use it here, or I put it up here at the top of main, because I'm not using it in this code here, so it doesn't matter. But I can't put it after I try and use it. So the order in which you do it, like you can't see out before you've done your equation. You can't declare it until you have to declare it before you can do your equation and before you can see out. And so you have to watch for that. So if it ever says it wasn't declared, probably just means that that needs to be moved up before something. And then if it's talking about declaring it more than once, that's probably just because you copied and pasted and you have the declaration on there multiple times. So I really want everyone to understand, do you know what float is? Do you know what int and double? Do you understand what that's doing? Everybody okay with that? That's setting aside storage. And some programming languages, you don't have to do that. It does it for you, like Python. You don't have to say what data type it is, but a lot of languages you have to say the data type because that depends. The data type tells the programming language how much storage space is required. In case you don't initialize it right there and you put values in later, it tells it what's needed to store it later. So when you're saying float, it knows how the minimum and the maximum that can be. It knows how many bytes that it can store and what type of number it can store. And when you say int, it knows what type of number. So it knows how much space to set aside for your variable that you're going to use later. So that's what you're doing. And that's why you don't have to do it multiple times because you already told it one time. You don't have to keep telling it. So it does get upset if you do that. Yes. Did you have a question?
Yes. What is the unsigned C equals time used for this?
Yeah. So unsigned just means that it's going to do like a positive number. So if you do unsigned, so time actually is like the number of seconds since 1970.
Yeah.
And so it pulls that and it uses that seed to do like the random number, because if it doesn't use a seed, and the seed changes because like the seconds, every time you run it, it's like a second later. So it's always a different number. If you don't, it actually keeps pulling the same number. Like if you use random, but it looks like it's different because if you do it again, it'll pull another number. Like if you do three randoms in a row, it'll pull them. But then when you do it again, and we did this last week, it pulled the same 3 random numbers because it seeds it with the same value. So if you seed it with like a number that changes, it could be, you could write your own seed.
Okay, I was upset. So you're just using time.
Yeah, just because it's always different. So because it's the number of seconds, and the computer does it for you because it pulls the number of seconds on your clock on your computer. So it knows, and you don't have to write your own like generator to generate a number or anything like that. But yeah, you can write your own generator to generate a random number, a seed for your random number, but it's the computer will do it for you. So it's pretty cool. And it's always, because it does it in seconds, every time you run it will be a different number. Well, you know, it can be a different okay, so yeah, so I wanted to, this one doesn't have any CNs. If you wanted to, you could take this program and you could try and add CNs to change the min and the max, and see if you want to practice with that. But I showed you a CN, so hopefully that makes sense to everybody if you know how to do that. The only problems with the CNs that you want to be aware of, and in the chapter it talks about this, is if you're taking in strings and you're taking in chars, like the characters of data, because of the way that the spacebar and the enter and everything register, it can mess up your string or mess up your chars. So usually instead of using CN for strings and for characters, because I showed you that program last time where if you're taking in just like one name in a string, it's fine because when you hit enter, it registers. But if you're doing like a first and a last name, when you hit spacebar, it gets confused and it jumps to the next one. So you want to use getLine instead of CN when you're doing strings, because you'll be able to type in multiple words with spacebar and it'll take in a whole line instead of just one word. So if you're doing multiple words, getLine works better for that. Yes.
You need line 4 to get what you were getting. See.
This thing?
Yeah.
Yeah, so this one works with the time. It won't know what this time is. And this one does the random. It does like it has the random one. So I believe if you take it out, it won't let me do it. No, maybe I don't. I thought I did. No, never mind. I don't know. I thought it was the random was in there. Okay. Let me see. Yeah. I guess you don't. I thought the random was in there.
I don't know. And what's the difference between like rand and srand?
So this one will get we'll seed it so that rand gets seeded with whatever the seed is that you have here. It'll put that time in there for you, and then they'll set up this one for you. So when you use rand, it'll use whatever you used up here. Sorry guys, I don't know my libraries as well as I know the Java libraries. I'm just starting back again with C++. I took like a 15-year break. And then I just started again last semester with C++ because we needed more to teach more C++ classes. So, so sometimes it's interesting, the differences and everything, and then, so, yeah. All right, I guess I thought that was the random one. So, okay, so what I want you to do for me is I want you to try and do this program. We're going to convert this real simple Fahrenheit to Celsius program, and we're going to do input, okay, on this one. So I want you to ask the user for the Fahrenheit. Okay, so you need a CN and you need to have a question with it. And then I want you to calculate the Celsius. And the equation is this, I'll give you the equation. It's Fahrenheit minus 32 divided by 1.8. That's probably the easiest way to do it. And then display, so do your output, the Celsius. Now you can display the Fahrenheit as well, but since you're asking them and you're seeing in the Fahrenheit, you already have that value. So you don't really need to display it. And then once you get that done, go ahead and make sure, like, practice with the formatting of it, do like the fixed and see if you can get 2 decimal places for it. So let's put in here 2 decimals. Okay, so you can do the formatting for it. While you're doing that, you can use online GDB or you can use Visual Studio, whichever is easiest for you. I'm going to go ahead and take attendance. And then I'm going to actually show you what I came up with for it. And you can tell me if that's what you got, or if you had any questions, if you got stuck along the way. So see if you can do it, because if you can do it, then I think that you're understanding what we're doing. And if you have any questions, we can go over that. So I'm going to go ahead and